Hello friends, myself Dattadre Jadhav. I am from HM College Karate. In our previous videos, we will learn about some operations on sets, that is complement of two sets, complement of a set, union of two sets, intersection of two sets. Today we are going to discuss some another operations on the set. First operation is here difference of two sets. Difference of two sets. The two sets, if A and B are any two sets, then difference of two sets A and B is denoted by A minus B. Is denoted by A minus B. Difference of two sets A and B is denoted by A minus B, and difference of two sets B and A is denoted by B minus A. Look at here. It is a difference of two sets A and B, and it is a difference of two sets B and A. A minus B and B minus A are not equal, and it is defined as set of all X such that it is a set of all elements of X such that X belongs to first set, that is A. X belongs to A. X does not belongs to B. It is a set of all elements of X such that X belongs to A. X does not belongs to B. Okay. For example, I am writing here a set A is equal to, it's 1, 2, 3, 4 and 5. A is set such that A is equal to 1, 2, 3, 4, 5. Take another set B. B is such that B is equal to, B is a set 3, 4, 5, 6, 7. Now we define A minus B as, therefore A minus B is set of all elements of A which are not in, set of all elements of A not in B. Look at here, 1 is in B, no, so write there. 2 is in B, no, so write here. 3 is in B, yes, don't write. 4 is in B, yes, don't write. 5 is in B, yes, don't write. It is set of all elements of A only, which are not in B. So A minus B is clearly set 1, 2. Okay. Now we show this set A minus B by a Venn diagram. A minus B, here is A minus B. Look at here. Suppose it's our set A, it's our universal set, and it's our set B. Now A minus B is a set of all elements of X such that X belongs to A. X is in A, elements of X belongs to A, but these elements are in also B, so A minus B is nothing but that set, shaded portion, A minus B. Now we are moving to our second definition, similar. Difference of two sets B and A is denoted by B minus A. Difference of two sets B and A is denoted by B minus A, and it is a set of all elements of X, or we can write this as set of all elements of Y, such that X belongs to first set. Which is first set here? Here is B. X belongs to B, but X does not belongs to A. Look at here. Remember when subtraction of or difference of two sets B minus A is taken, then elements are from set B which are not in A. So B minus A can be defined as, for example, B minus A is equal to, I am writing here B minus A. 3 is in A. 3 is in A. Yes. So don't write. 4 is in A. Yes. Don't write. 5 is in A. Yes. Don't write. 6 is in A. No. So write. It is a set of elements in B which are not in A. 6 is not in A. So I am writing 6 there. 7 is not in A, that's why I am writing here 7 also. So B minus A is nothing but set 6, 7. Look at here, A minus B and B minus A are not equal sets. So here from our definition we represent B minus A. We represent B minus A as I am shading that portion by yellow chalk. B minus A. B minus A is nothing but it is elements of B. So these are elements in B. By Venn diagram, these are elements in B. But these elements are in A. So we can't take these elements. Okay. So this portion of vertical lines represents the set B minus A, and we know that middle portion. We know that middle portion is what? It's A intersection B. That middle portion is denoted by A intersection B. Remember, B minus A is set of elements which are in B, not in A. A minus B, set of elements in A which are not in B. Now, there are some notes here. There are some notes for difference of two sets. Difference of two sets. Clearly, that shaded portion. Yes, A minus B union B and A intersection B and B minus A is clearly A union B. If I shade that portion, which portion? A intersection B. That shaded portion is clearly A intersection B. So, I am writing here first property or first note, A minus B. A minus B. A minus B is set is here. This set is A minus B. Okay. A minus B is a subset of A minus B is subset of A. Clearly, A minus B is a subset of A. Now, second property or second note for B minus A. B minus A. B minus A is clearly subset of B. B minus A is clearly subset of B. I am taking here example. Clearly, A minus B is set of 1, 2, and A minus B is clearly subset of A. And B minus A, here B minus A is 6, 7. So B minus A is subset of B. Okay. Two notes are there. A minus B is subset of A and B minus A is subset of B. Third note is here. Third note is here. A minus B, A intersection B and B minus A. Look at here. A minus B, this set. A minus B, this set. B minus A. B minus A is this set. Okay. And what? A intersection B. These three are mutually disjoint sets. these three are mutually disjoint sets. Mutually disjoint means, yes, there is no common element. There is no common element in between these three sets. If I find here A intersection B, for above example, yes, A intersection B is common sets, common elements. Which are common elements in A and B? 3, 4, 5, 3, 4, 5. So intersection B is 3, 4, 5. Okay, and A union B, if we find here A union B means set of elements which are in A or in B or in both A and B. So I am writing all the elements in A and B. It's 1, 2, 3, 4, 5. 3, 4, 5 is included. Don't write twice. 6 and 7. So A union B is 1, 2, 3, 4, 5, 6, 7. Look at here, these three sets. First one is A minus B, second one is B minus A, and third one is A intersection B. These three sets, here is 1, 2, here is 6, 7, and here is 3, 4, 5. There is no any common element in between these three sets. So these three sets, A minus B, A intersection B, and B minus A, are called as mutually disjoint sets. Fourth note is here. A minus B can be also write as A minus B. Look at me. I am showing A minus B here again. Here is our A, here is our B, and that shaded portion is nothing but, yes, it's A minus B. Look at it. A minus B. It is clearly elements of A. A minus B is elements of A which are not in B. So not in B, for that I denote dash. And if we take intersection of these two sets, A intersection B dash, then it is clearly A minus B. A minus B is nothing but A intersection B complement. A intersection B complement. B complement is what? Look at here. B complement is ह्या B मधले सोडून बाकीचे सर्व. म्हणजे हे बाहेरचे. मी त्याच्यासाठी पिंक चॉक यूज करतोय. कन्सेप्ट क्लिअर झाले पाहिजे वेन डायग्राम वरून. ओके, हे बाकीचे म्हणजे B मध्ये नसतात आणि त्याचे इंटरसेक्शन कोणाबरोबर घ्यायचं तर A बरोबर घ्यायचं. A बरोबर इंटरसेक्शन घेतलं तर ज्यामध्ये पिंक आणि व्हाईट लाइन्स आलेले तो म्हणजे तुमचा असणार आहे हा, यस, A minus B. A minus B is nothing but A intersection B complement. Similarly, fifth is nothing but for B minus A. I am also showing that by Venn diagram. Here is set A, here is set B, and these elements, which elements? The horizontal lines in B. These elements is nothing but, yes, it's B minus A. Clearly, B minus A is elements in B. So I am writing B minus A is equal to B. Which are not in A. So I am writing here A complement. B minus A is nothing but B intersection A complement. B minus A is nothing but B intersection A complement. एक साधी गोष्ट सांगू, इथे a मायनस बी घेत असाल तर a मायनस बी म्हणजे असे एलिमेंट्स असणार आहेत की जे a मध्ये असणार आहेत आणि इंटरसेक्शन घ्यायचं दुसऱ्याचं म्हणजे b कॉम्प्लिमेंटचं. इथं b मायनस a घेतोय तर b मध्ये एलिमेंट्स असणार आहेत आणि इंटरसेक्शन कोणाबरोबर घ्यावं लागेल दुसऱ्याच्या डॅश बरोबर. b minus a is nothing but b intersection a complement. Okay, next sixth काय सांगतोय तर आता आपण पाहिलेलं आहे a युनियन b काय आहे 1 2 3 4 5 6 7 a युनियन b. जर मी a minus b minus a आणि a intersection b, if I take union of these three sets, then it is a set of elements 1 2 yes 3 4 5 6 7, which is nothing but a union b 1 2 3 4 5 6 7. Okay, so sixth property is a minus b union a intersection b union b minus a, it becomes a union b. जर आपण a minus b minus a आणि a intersection b या तीन सेटची युनियन घेतली तर ती तुम्हाला काय मिळणार आहे a union b. बघा इथं अजून एकदा a minus b 1 2 आहे, a intersection b 3 4 5 आहे आणि b minus a 6 7 आहे. या तिघांची युनियन घेतली तर ते काय आहे 1 2 3 4 5 6 7. लक्षात आलेल्या आहेत गोष्टी. आपण आता काय केलेलं आहे डिफरन्स ऑफ टू सेट्स. आय एम रिवाइजिंग दॅट कन्सेप्ट अगेन. a minus b and b minus a both are not equal. a minus b is set of all elements of x such that x belongs to a, x does not belong to b, and b minus a is a set of all elements of x such that x belongs to b, x does not belongs to a. पुन्हा एकदा बघा a minus b म्हणजे a मध्ये असणारे b मध्ये नसणारे, b minus a b मध्ये असणारे a मध्ये नसणारे. ओके, वेन डायग्रामला हा पोर्शन जो आहे हॉरिझॉन्टल लाईनचा तो आहे a minus b, वर्टिकल लाईनचा पोर्शन आहे तो आहे b minus a आणि हा जो मिडल पोर्शन आहे तो काय आहे a इंटरसेक्शन b. प्रॉपर्टीज किंवा नोट्स काय सांगतायत आपल्याला a minus b हा a चा सबसेट असणारच आहे. तो दिसतोयच आपल्याला या ठिकाणी a minus b हा a चा सबसेट आहे, b minus a हा क्लिअरली b चा सबसेट आहे. a minus b a इंटरसेक्शन b b minus a म्युच्युअली डिस्जॉइंट सेट्स आहेत. a minus b हा हे सर्वात महत्त्वाचं आहे आपल्याला. a minus b हा कसा लिहू शकतो मी a इंटरसेक्शन b कॉम्प्लिमेंट, b minus a कसा लिहू शकतो b इंटरसेक्शन a कॉम्प्लिमेंट आणि a युनियन b जर तुम्हाला 3 सेट्स मध्ये लिहायचं असेल तर a युनियन b असं असेल a minus b युनियन a इंटरसेक्शन b युनियन b minus a. थोडंसं पुढे जाऊया. नेक्स्ट फिफ्थ ऑपरेशन इज हियर ऑन सेट सिमेट्रिक डिफरन्स. फिफ्थ ऑपरेशन काय आहे तर सिमेट्रिक डिफरन्स ऑफ टू सेट्स. The notation for symmetric difference of two sets is denoted by this delta. Delta stands for symmetric difference. The symmetric difference between two sets A and B is defined as or is now denoted as A delta B. The difference symmetric difference between two sets A and B is denoted by A delta B, and it is clearly the union of two sets A minus B and B minus A. It is clearly defined as A minus B union B minus A. Means in Venn diagram I am showing that symmetric difference A minus B, suppose it's set A, it's set B, and it's a universal set, say U. A minus B is here. Okay, B minus A, it is a set of elements in B, not in A. B मध्ये असणारे A इथले एलिमेंट्स आणि ह्या दोन सेटची युनियन त्याला आपण म्हणणार आहे सिमेट्रिक डिफरन्स A डेल्टा B. For example, take similar example. A is equal to 1, 2, 3, 4, 5. Okay, B is equal to 3, 4, 5, 6, 7. Now define A minus B. A minus B. Tell me A minus B is what? Elements in A which are not in B. 1 is in B. No, so write directly. 2 is in B. No, write directly. 3 is in B. Yes, don't write. 4 is in B. Don't write. 5 is in B. Don't write. Bracket complete. Here is A minus B. And B minus A is what? B minus A is elements of set B. It is a set of all elements of B which are not in A. 3 is in A. Yes, here is 3. 4 is in A. Yes. 5 is in A. Yes. 6 is in A. No. So write them. 6, 7 is in A. No. So write here. Now the symmetric difference between two sets is, yes, A delta B is equal to A minus B union B minus A. A delta B is defined as here A minus B is 1, 2, union is unique 6, 7, which is equal to, yes, 1, 2, 6, 7. This it is our symmetric difference A delta B. Okay. Now there are some properties. There are some properties of symmetric difference. Properties are very easy. First one is A delta B. Definition is here. A delta B is nothing but, yes, A minus B union B minus A. A minus B union B minus A. Now another form of A delta B, or we say that symmetric difference of A and B, is clearly it is that shaded portion is elements in A and B. Elements in A and B. But which elements are not there? These common elements, that is intersection. So I am writing A union B minus A intersection B. So A delta B is equal to A union B minus, yes, A intersection B. It's our first problem for symmetric difference. If we take the symmetric difference with itself, then we get 5. Because A delta A and A delta A both are same, so they cancel with each other, and difference is what? It's 0. Third one is, if we take symmetric difference with 5, A delta 5 is equal to, it is clearly A. Fourth property, A delta 5. If we take symmetric difference of A delta 5, look at here, I am explaining that third property. A delta 5 is equal to, yes, from the definition, A delta 5 is A minus 5 union with phi minus a. A minus phi. A is what? A is set of 1, 2, 3, 4, 5. A minus phi. It is elements in A which are not in, yes, phi. That is all the elements 1, 2, 3, 4, 5. Okay. And phi minus a. Phi minus a. Phi minus a element in phi which are not in A. It's again clearly empty. So union of these two sets is 1, 2, 3, 4, 5. What is this? It's A. A delta phi is equal to A. Next, A delta B is equal to A delta C. Then we say that B and C are equal sets. If A delta B is equal to A delta C, then B and A are equal sets. Fifth property is here. Fifth property of symmetric difference is here. A delta B and B delta A both are same. A delta B is equal to B delta A. Look at it. Here we find A delta B. Now I am finding what? B delta A. B delta A is what? I am writing here B delta A. B delta A is, yes, B minus A union with A minus B. Changing only signs. We know that A minus B union B minus A is equal to B minus A union A minus B. Union is commutative. So B delta A is similar as A minus B union B minus A. So simply, which is our definition of A delta B? So here are the fifth property. A delta B is equal to B delta A. Okay. Now moving to our next two laws. Two laws are here. First one is distributive law and second one is De Morgan's law. Distributive law and De Morgan's law. There are two laws for distributive. First one, A union B intersection C, and second one is I am explaining after somewhere. A union of with B intersection C is equal to, its union is distributed over intersection and it becomes A union B intersection with A union C, and after interchanging union by intersection and intersection by union, we write second distributive law. A intersection with B union C is nothing but A intersection B, yes, union with A intersection C. These two laws are called as distributive law, and here is last one, De Morgan's law. De Morgan's law, only statement is here. You are already learned about this. A union B bracket complement is equal A complement intersection B complement, and second one is A intersection B complement is equal to A complement union B complement. You verify these two laws by taking examples or by using Venn diagrams. I am explaining here only De Morgan's law. First, A union B. This is A union B. I am taking two sets. Here is set A, here is set B. Now A union B is set of all these elements. Yes, it's A union B, and we want want to take in that complement of A union B. So which elements are here? It's set of all elements. It's our A union B complement. Okay. Now I am taking RHS of this De Morgan's law. A dash intersection B dash. First I am find A dash and second intersection with B dash. It's our A, it's our B. So A dash is what? A dash is set of elements which are not in A but in U. This set is nothing but A dash, shaded portion. And about B dash, yes, for B dash, it is set of elements which are in U, not in B, not in B, these elements for B dash. If we take intersection, that is common portion, then look at it. It's our A, it's our B. The common portion taking intersection means common portion. The common portion is, look at here. This portion is not common, this portion is not common. The remaining portion is common. Which portion? It's, yes, outside the A union B. And look at here. These two are same. So LHS is equal to RHS. So students, today in this video we learn about remaining operations on set, that is difference of two sets. Second one is symmetric difference of two sets, and two laws are here, distributive law and De Morgan's law. I hope you understood today's operations and laws on sets. Thank you for watching the video.